moving nice and quick. We have our next guest already ready to go, Sofia Pippolis, who is actually has been working on a Seek Commons grant on figuring out ways to develop open hardware documentation. How are you doing, Sofia?
Good, good. How are you? So thank you so much for inviting me. And we've seen such amazing projects. Now we're gonna talk some more about these projects, and I would actually like to share a presentation to show you what we have done with Seek Commons. So let's see. It doesn't seem that it's working. I don't know why.
There's always a fun little moment
Yeah.
to figure out a new system. So it should be the little screen with the plus sign in the middle.
Yeah, I saw that, but it says that the browser doesn't have access to
Permissions.
my screen.
Sometimes that happens. Another option you can do is you could send me the link in the private chat, and I
Yeah,
can
I have
scroll
it
through
right
them.
here.
Yeah, I can scroll through the slides for you.
Yeah, let me do that right now. So here it is. So yeah, what the purpose of this project, I can start talking about it. But as I said, it's in conjunction with OSHWA and Seek Commons. And if we go to the next slide, so we can see the slide. So that's amazing. Thank you. I just wanted to talk a little bit more about this certification because everything starts with the project, as we saw. We saw some amazing projects, and in the OSHWA website, it's also possible to see certified projects, and it's possible to search for them. It's possible to filter them. So there is a list of these projects, and we can also search by keyword or category. The important point is that these projects are organized, and we can make them more available by disseminating them and creating a data model for them. So if we go over to the next slide, thanks. We can also see that when we click on a project, we have information about it. For example, we have, of course, the title. We can click and see the project website, which can be everything. It can be a scientific article. It can be a proper website. It can be GitHub. And we have the ID, and we have the project type. So we have a lot of information for each project. And if we go over to the next slides, I can explain the goals of my project were to create a data model for OSHWA on Wikidata so that these projects could be queryable, but in general so that people could add their own projects there, also in the future maybe, to assess the state of the OSHWA projects, so where are we at, and to create a validator that automatically checks projects basing on the data model. So I'm gonna start with the first one. If you go to the next one, so it's this one. So why a data model? What is a data model? The idea is that when we search something on Google, for example, a person, a composer, songwriter, we have some information about them. For example, it can be the birth and the death date. It can be website where we can see their music. It can be some like Wikipedia notes. It can be many things, sometimes the height of a person, sometimes important books that person has written. So all of this is general information that we get, and we get that because there is a data model on Google, or better, a knowledge graph, something that connects information and that knows that when we search for a person, we might want to know about the birth date, and that if the person is an artist, we might want to know about their art. So this is pretty important for many kinds of reasons, especially when we search. So it's important that we have that for every kind of data, including OSHWA projects. So if we go to the next one. So the point is that there is Wikidata that helps gather this information. And Wikidata, as we can see, has some properties and some information for each person. So basically, we have statements that concern different kinds of information that we might want to represent. And we have specific IDs for those entities. So we can have all kinds of entities, not just people. And we have identifiers so that people can look for them, but also so that they can show up in other places. They can show up on search results, they show up in LLM's results for sure. So they can be seen by other people and also connected to other kind of information. For example, if a project is of the type agriculture, we can look other project of that kind, and we can make queries based on specific properties. So if we go on the next slide, we can see that the point of a data model is to effectively connect information, so that information is not repeated, it's just connected. And of course, information is ever growing, so we really need to connect all these pieces as information scales. So if we go over to the next slide, we can see that my idea of the data model for OSHWA was to have three main conceptual layers. So the point is to represent projects, and one of them is the identities and scope layer. So we have basic metadata. The other one, of course, concerns the license and general documentation for what concerns the certification of the project, because of course, when a project gets certified, what is seen is the documentation of it. And then we have also the compliance and versioning part, which is quite important. So what does it mean to be compliant to OSHWA certification? So I'm gonna go over these three parts. If we go to the next slide. So the identity and scope part has different properties. A project, first of all, has to be an instance of OSHWA, so it has to be open source hardware, has to have a name, and has to have a certification ID, which is was not present in Wikidata. We added that one so that everything could be query. Yeah, thank you. So we have also the project type. It's important to divide projects by domains, especially because there are so many now. So it's very interesting, and also the country of origin. Then if we go over to the next one, we see that there is also, of course, information about licensing. So hardware license, software license, also information like design files and formats they are available in. And if we go over to the next slide, we see the maybe most important part, which is about the compliance to OSHWA. If we go to the next slide. Thank you. Thank you. Sometimes it lags a little bit. So the idea is that a project is well made. First of all, if files are easy to make, so to find. So of course, it also concerns compliance to the FAIR principles. If the open parts, for example, are clearly indicated, or if the OSHWA mark is applied correctly. Other things are, for example, that we know we have the release label and the version on software. If we have the license on the documentation, if we have a design file, for example, that has editable format. Sometimes we don't have to have the design files, but these are general guidelines, of course. Other information is, for example, the documentation replication quality, if the documentation is free of charge, if it contains images. Of course, basing on the specific project, this compliance varies, but just so we know that people manually verify these projects. So, of course, this information may vary, but it's important to have some general guidelines, something to start from. So if we go to the next slide, we see that, first of all, as I said, the OSHWA identifier has been proposed as a property and has been accepted. So now we can finally add the information. And what I did was to start adding and connecting information on OSHWA projects that especially concern scholarly articles. There are about 60 of them, and I'm gonna talk a little bit more about that. But before doing that, I want to show a specific thing. If we go to the next slide, which is that basically when we create a data model, this forces us to ask what exists. So in this case, what exists in OSHWA certified projects. And if we go to the next slide, we see that one thing that I mentioned was these scholarly articles. Now I'm going to talk about the state of the OSHWA projects. So if we go to the next one, what I mean is that sometimes there are projects that either as a project website or on GitHub have references with DOIs to scientific articles that use actually hardware. So that's very useful. That's very interesting. It also allows us to track information about project development and usage across and dissemination on the web. So it's very interesting. And what we did was to add this information on OSHWA entities. Another thing that is important that we're gonna see in the next slide is that sometimes, because some projects have been created some time ago, some project links are dead. So there is this 404 error sometimes pages require to sign up. Sometimes the page could exist, but the URI is just wrong. So in this case, for example, of the SparkFun website, the product did exist, but because they changed the URLs, then everything was broken and was not linked again. So what we did was also to look at this information. This is very important for you. So of course we wanted to make sure that everything was linked, and so every link had to be proper, had to be reachable. So if we go to the next slide, we have some examples as I shown, and there are more than 200 projects that were unreachable. Some other pages were reachable but still problematic. For example, Google Docs were used. This is not problematic per se, but it also prevents a little bit of archival versions. Another example was to use Facebook and social media in general as the main page. Of course, it's very good to promote projects on social media, but this should be not the place where you put documentation in general, because social media is susceptible to all kinds of changes, and you don't even know if the page is gonna be there after 1 year or 6 months for any reason. So in the next page, we have a solution. So we contacted people that had broken links, and some of them were already solved really quickly. So SparkFun pages, for example, now are all functioning, and this took really little from them. So if we go to the next page, we can see that we have now the third goal was to create a validator. So basically an algorithm that automatically checks projects basing on the data model. This is not going to be perfect, of course, because every project is different, but it's still something that can be supportive of some kind of things. For example, these broken links. So if we go to the next page, I can show the design the principles, and the idea is that we don't want to use AI or LLMs for that. Probably they could be successful, but we're not going to do that. It's a simple algorithm that checks documentation quality, license compliance, as I said, academic research objects, that pages, Also contact and social media information, visual assets, and general metadata, for example, uptake. This is important, so some projects might have many stars, so we could keep track of them. So to the next page, we also want to say that the outputs are just documents. So we have analysis data, we have a human readable report and a table of academic references. We did not create a scoring system, so like ranges of software of hardware quality on purpose. We believe that this should be a helpful tool, but of course it's not perfect, and also its usage is not meant to provide a score. So to the next page, I can just talk about the usage. So basically, what are the uses of this validator? If a new project needs to be certified and has a link, which probably does, it's possible to use the validator to have an idea on how compliant the project is with respect to certain indicators maybe. But also if people would like to submit to OSHWA, they could use the validator themselves to see if there is something that they could improve. Maybe they didn't notice that the documentation was poor in some parts, or maybe not. And also with the validator, it's possible to assess all projects for different metrics. So it's possible to go back and see how many stars did the project have, if the link is broken, if some more, for example, DOIs or research objects have been uploaded that weren't tracked off before. So these are the main usages. We're still working on this, but the idea is to provide something that, of course, can be used in the community and to make everything reachable, basically. So if we go to the next slide, I just want to thank you so much. And this is my email, but I also want to thank OSHWA and the SIG Commons projects for every support that I got. Also, thank you for helping me with these slides.
Oh, no problem.
No
With the
worries.
patience.
Sorry, the technology is always so weird.
Always. I don't know why.
To hear about how this project came together. It's been really exciting to see this develop. And I mean, honestly, a thing we are always trying to find solutions for is the reality of documentation can be complicated for
Yeah.
people. So this is a really great way to really consider ways that folks can explore that and play with it in more ways.
Thank you. Yeah, we're always also looking for more ideas. So every suggestion is always welcome, of course.
Amazing. Make sure you get in contact with Anna Sophia if you want to do some more work to help develop this data set. And thank you so much for coming by.
Thanks.
Thank you. Thank you. Thank you so much.